Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good evening to Dr. Ahmad Sabri. So we are going to present about the assignment 2 and our group members are Amirul Ashraf, Dania Batrisha, Awanis, which is me, and also Muhammad Nasrul Aizad. Next. So I'm going to present about our question. So we as a civil engineer are required to design a program in determining the best pavement material. So to ensure the safety of a citizen, we must print the results of the best material with the least deflection based on its material temperature and also the toughness. In addition, the user can also choose the desired shape and size of the pavement, which is rectangle and also triangle. So the formula for the toughness is final length minus initial length over initial length. And there are three materials that we need to test it. First is integrated concrete pavers. Second is open graded asphalt concrete. And lastly is Portland cement concrete. So next. Here is our data from the integrated concrete pavers, and we give to the user temperature, deflections, final length, and also the initial length. Open graded asphalt concrete, and lastly is for Portland cement concrete. So that's all for the question, and for the coding, I will pass the floor to Dana Batrisha. Please welcome.
Hi, I'm Dania. I will present on the first part of the coding and the first menu for the coding. We call the library of iOS stream fstream, cmath, vector, and iomanip. This is because we are going to call the library throughout our coding. Then we will declare temperature and option as integer. Option is declared as 1 so that the do while loop can be executed as the statement is true. Then we will declare deflection, final, initial, and toughness as double. Then we will display to the users the types of calculator this coding gives, which are pavement deflection calculator, toughness calculator, and the shape. We have many loops in this coding. The main loop would be the do while loop, and in this do while loop, there is one switch repetition loop. In this repetition loop, there are 3 cases, and in every case, there is 3 cases for every material. In the first case, we are declaring option as integer. This equals to 1 for the same reason, which is to execute the do while loop as the statement is true. Then declare deflection and lowest SD as double, temperature as integer, and in file if stream. This is because we are using stream to read data from text file for every material. If the user inputs the first calculator, then we will display the pavement deflection calculator main menu. Then we will ask the user to choose which material does he or she want to calculate for this deflection calculator. If the user inputs as 1, then we will go with switch case 1. In the switch case 1, we are declaring sum mean, sum SD, and SD as double. The sum and mean and sum SD is initialized as 0. This is because we are calculating the total to get the least deflection. Then we will declare vector of total deflection and total deflection SD as data type double. Then we will open the text file with this path location. After that, we have while loop, which will read the data in the text file for this material. The sequence of the data in the text file is temperature, then deflection, final, then initial. We are only considering temperature and deflection for this case. After that, we will calculate the sum of deflection. Then the total deflection will be input. The deflection will be input into the total deflection vector using pushback. After this while loop, we will calculate the mean by sum divided by 20. We are dividing by 20 because we have 20 datas. Then we have if total deflection vector is empty or not. If the vector is empty, then we will display in the output screen vectors empty. After that, we have for loop. It starts with index 0, and when the index is lesser than the total deflection size, we will execute total deflection vector. The values in the bracket will be pushed back into the total deflection SD vector. Then we will calculate the sum SD with sum SD adding up to total deflection SD vector. After this two statements is executed, we will add up the index by 1 until it does not satisfy the condition of I less than total deflection size. After that, we will calculate the SD, which using this formula, we are using square root. That is why we call the CMath function at the start of the coding. Then float lowest SD equals to SD. Since this is case 1, then this is how we are going to calculate the lowest standard deviation. This will be different for case 2 and case 3. After that, we will display the mean of reflection and standard deviation of deflection for case 1, which is the first material. After that, once the user inputs case 2, which is second material, is the same thing. The difference is the path file location, as each text file is for different type of material. The other difference is to calculate the lowest SD. If the current SD is lower than the lowest SD, which is initialized in the first case, then it will be replaced. After that, the same thing, we will display it. Same thing goes for case 3. It's just different file location and also the lowest SD. After that, once the user inputs as 0, the coding will end for the first calculator. Then we will go back, we will display the best pavement material has the worst standard deviation and display the lowest standard deviation. Then the user will know which material is the best material regarding the standard deviation. Then we will move to the main menu, which will be displayed in the output screen. Okay, user inputs of 1, which is the paper deflection calculator. Then we can pick the material. Let's say user input 1. Then it will display the mean of deflection and standard deviation for this material. User inputs 2. It will be for the second material, and the user inputs 3. Same thing for the third material. That is for the deflection calculator. Once presses 0, we will display the best material regarding standard deviation, which has the lowest value. That's all for the first calculator. I will pass the floor to Amirul for the second calculator.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Amirul Ashraf. So today I will explain about the case 2 on our program. So in the case 2, declaring the integer option equal to 1, same goes to the case 1 because I want to perform the Swiss option over here. So then declaring float data type highest mean, then use the function if stream in file because we want to open the file using text file. Then this is where the user will see the pavement toughness calculator using the do loop, because using the do loop over here, then using the switch case option function to let the user to choose between the case 1, case 2 or case 3. Okay, so I will explain about the case 1 first. In the case 1, I'm declaring double data type for sum and mean. Then using vector double to store the data of total toughness. Okay, then this is where I use the in file stream to open the file. This is the path of the file where I store it. So for the integrated concrete paver toughness, so using the while loop, so in file and off file. So this is the sequence of the file: temperature, deflection, final, and initial. So final and initial is the reading for the pavement. So calculating the toughness using the formula final minus initial over initial. Then also calculating the sum equal to sum plus toughness. Then calculating the mean of the material using the formula sum over 20 because I have a 20 data. Then declaring the highest mean equal to mean. Okay, this is where I can want to find the highest mean from the tree material. So, for the case 2, the same goes for the case 1 for the coding, but the difference is at here, at where the data is being stored, and the second one is here, where we want to find the highest mean of the tree. So if the second case, the mean is higher, this will be replaced by the first mean. Okay, but if the first mean is higher, then it will maintain. So same goes to case 3. So in case 3, this the difference are at here, where the user where the location of the text file is different, and also the where the replacing of highest mean done. So this is the code. Then after the user enter 0, it will be display the best pavement material has the least difference in length, and see out the highest toughness, and show us the highest mean from the calculation, and it will direct back to the main menu. Okay, I will show you the output of our program. So this is our output. So from the main menu, you need to choose to go to pavement toughness calculator, and you enter 2. Then welcome to pavement toughness calculator. Below our choice of pavement material, you enter 1 for the integrated concrete pavement toughness. Then enter 2 for open graded asphalt concrete. Then enter 3 for Portland cement concrete toughness. Then when you want to back to main menu to see your result, then you enter 0. It will show you the best pavement material has the least difference in length. The highest toughness was 7.125. Okay, so that's it. Okay, that's all from me.
Okay, my name is Muhammad Nur Saizat, and I will be explaining the last menu, which is the shape menu. And we will ask the user to choose which shape of pavement that you desire, with either triangle, rectangle, or. So our first variable is integer, which is choice, width, height, row, and size, IGK. So as we can see, this is our selection menu for each shape. So in the first case, for a rectangular shape, our variable is height and width, which we declare as integer. We ask the user to enter the height and the width value. Next, we use nested loop to make the rectangle shape using asterisk. So for example, if we run the program and I enter 9 as my height and 3 as my width, we can see that the rectangle shape will produce on our screen. On the outer loop, we initialize I is equal to 0 and I must be less than height, which is 0 is less than 9, and it will execute the inner loop j, which I initialize as 0, and j must be less than 3, which is it will be print the asterisk repeatedly for 3 times, and it will go back to the outer loop for the second line and repeat the same process as the first one until I is equal to 9, and it will break and show the final output of the shape and repeat to the next program, and it will ask us to enter the next choice. So for our next case is the second one. The second one is slightly same as the rectangle, but we're only using row as our variable. So for the input, I will enter 4 as my triangle row, and in the for loop, integer is I declare as equals to 1, and I is less or equal to row, which is 4, and I plus plus. So it will execute the inner loop. So in the inner loop, integer is j equals to 1. J must be less than I, which is the row, which is 4, and j plus plus. And it will print the asterisk for one time. So we will repeat again in the outer loop. For I is less or equals to 2, I plus plus, and it will execute in the inner loop, and j is less or equals to 2, j plus plus. So it will print the asterisk 2 times, and it will repeat the same process until until I is equals to 4. Thank you.